27 over 64. Make sure I have my powers of 4 correct. So this is our answer here. Okay, cool. So there are certain situations where the matrix is not really applicable, and this would be one. And what made this different? This was different than our other situations because not only am I specifying the beginning and the end of my, the beginning and the end, where I start and where I end, I'm also specifying what's happening in the middle, in between. So I'm saying that he's getting hit literally every time. So using the matrix isn't entirely appropriate here. Instead, we should just multiply these probabilities. Okay. I want to ask one more question based off this scenario with the baseball stuff. And then I'm going to do one different example, and then I will be done. So here is the third question on this scenario. If he hits his first ball, so he hits the very first ball, what is the probability that he hits the, I'm going to pick the second. So the second, I'll write the word second. It's the second and fourth balls. So what's the probability that he hits the second and fourth balls if I know that he hit his first ball? Okay. So this is a lot like the last one in the sense that not only am I specifying the beginning and the end, I'm also specifying one of the outcomes in between. I'm specifying what happened on the second ball, for example. And so again, in this situation, I don't really want to use the matrix anymore because I'm not just saying what happens at the beginning and the end. I'm saying that something specific has to happen in the middle, in particular, he's hitting that second ball too. And so it's not just transitioning from one state to another after a certain number of steps. There's something happening in the middle. And so again, when I have a problem like this, I think that maybe it's just easier to just sort of draw out the tree diagram or a transition diagram or something and finding the paths that'll work. So I think I'd rather just draw a tree diagram that containing all the stuff that meets this criteria here. I want to draw out the paths where he starts with the hit, hits it on the second time, and hits it on the fourth time. The question is what can happen on the third time? We didn't specify what can happen on the third time. So we have to leave open the possibility that he could either hit or miss on his third swing. So we have to account for that. So what does the tree diagram look like? Well, he has to start with a hit. Okay. And I'm also insisting that he hits on the second try. So that hit has to go to another hit. Now, on the third try, we don't know what can happen. He could either hit or miss because it's not specified here. We don't know what happens on the third hit. So we're going to branch off. And he's either going to hit on the third time or he's going to miss. We don't know. But those are the two possibilities. Either hits or misses. There's no weird in between allowed here. And then finally, on the fourth time, what do I know? I know he has to hit on the fourth time. So those have to transition to hit. So this would be like a tree diagram that represents this scenario here. And the last thing we need to do is fill in the probabilities that match. And we know what those are. Again, his probability of going from hit to hit we found was 3/4. And again, from hit to hit was 3/4. Hit to hit was 3/4. Hit to miss was 1/4. And miss to hit was also 1/4. Yeah. It's also 1/4. Okay. So now that I have that, what do we need to do? We just need to trace out the possible paths, multiply out the numbers, and then add them up, or the results. And so there are two paths through this tree, right? I could either start here and end there, or I could start here and end there. And so I just need to multiply appropriately for both of those paths and then add them up. So let's do that. So if I go along this path, I'm just taking 3/4, 3/4, 3/4. So that's our 3/4 cubed. And then if I go the other path, that's 3/4 times 1/4 times 1/4. So that's 3/4 times 1/4 squared. And what is that? Well, I don't know what that is off the top of my head. I don't think I wrote down the answer on this one. Let's think about it for a second. This is 27 over 64 plus 3 over 64. So I guess it's just 30 over 64. Or if you like, maybe that's 15 over 32. So anyway, 30 over 64 or 15 over 32. That's our answer here. Okay, so again, I didn't want to use the matrix here because I'm specifying something that's happening in the middle. And so it's better to maybe draw the tree diagram just to see exactly what the possibilities are in this situation. So the lesson here is that the matrix is not always applicable. It can't solve everything. Sometimes we have to draw a diagram or think about it in a different way. But when we can use the matrix, it's the better option. Okay. Okay, so I'm going to do one more example, which will be just a little shorter than this one. And then I will be done. So here's just a completely different scenario now. This one will be more abstract in the sense that I'm just going to give you a transition diagram. We'll give a transition diagram that looks like this. So this is 0.3, 1, 0.2, 0.5, 1. So here's our transition diagram for this situation. And here's the question. If we start at A, what is the probability of being at C, I guess at A actually, after 3 steps? So what's the probability of going from A back to A after 3 steps? Okay. So this is the kind of problem that we can answer with the matrix because I'm just saying what's the probability of starting in one state and ending at another state after some number of steps. So that's something where I can use the matrix. So we would find the matrix for this. Again, P is the following matrix. So these are like A, B, C, A, B, C. Probability going from A to A is, well, there's no arrow from A to A, so that's 0. The probability going from A to B is 1. The probability going from A to C is also 0. There's no arrow for that. From B to A is 0.3. B to B is 0.2. B to C is 0.5. And finally, C to A is 0. C to B is also 0. And C to itself is 1. So this is my matrix P, my transition matrix. Okay, so I'm interested in finding P3 because we're asking about 3 steps. So I would need to find P squared, then P3. I'm going to basically, so I'm not going to do the multiplication out for you. I'm basically going to tell you, because again, I trust you guys could take the multiplication of the matrix with itself. I'll just sort of give the answer here. P to the 3rd power, so P of 3, which is P to the 3rd power. Let me give myself some more room. P to the 3rd power is the following matrix. It should look like this. 0.06, 0.34, 0.6, 0.102, 0.128, 0.77, and then 0, 0, 1. So I invite you guys to try to work this out or check it in a calculator or something to make sure that you get the same answer. But this is what I got earlier. So this is our P3 matrix. And so the probability that we're looking for is, again, we're going from A to A after 3 steps. So again, if this is A, B, C, and this is A, B, C, I'm looking for A to A. That is this. right here, 0.06. So that's a pretty small probability. We're not very likely to end up on A after 3 turns if we start at A. And that should make some sense if we look at the diagram, because I always have, once I'm at A, I have to go to A at the next turn, basically, probability of 1 of leaving A. And then it's sort of a pretty small probability of going back to A, whereas it seems like there's a bigger probability of going back to C, it's, for example. So it doesn't seem likely that if I start at A, that I'll end up back at A after so many steps. So this sort of matches the intuition of analyzing this diagram and thinking about it. Okay, so that's good. Let's ask another question that we might be able to answer. I'll try to leave the diagram and the matrices up here for a second. Let's ask a new question. Here's the second question. If we start at A still, what is the probability of being at A the next 2 steps? So think about that for a second. If we start at A, what is the probability that for the next 2 steps, I will also be at A? Okay, so this is supposed to be kind of a, I don't know, not really a trick question, but it's maybe kind of a dumb question. And here's why. So if I'm starting at A, I'm asking what's the probability that I'm at A the next 2 steps? Well, so in particular, on the very next step, I have to be at A. What's the probability going from A to A? It's 0. So really, I'm basically asking, this would be my tree diagram in this situation. I would go from A to A to A. Well, what's the probability of A to A? Well, I told you that it's 0. And so 0, 0. So the probability is 0 times 0, which is 0. So the answer to this one is 0. This can't, statistically, this is not going to happen. The probability is 0. So the lesson here is read your problems very carefully. This one is 0. So, okay, that was kind of a dumb question. Let me give you a real one to finish us off.